Hello everyone, welcome to Cambridge YouTube channel. I am so happy to see you here once again. This is your only ultimate destination for learning chemistry. I am your tutor and your host, Andy Kofi Ago, and today I'll be taking you through naming alkanes using ISO, SEC, Tert, and NEO. To start, I'll help you identify what is a primary carbon, a secondary carbon, and a tertiary carbon. Let's look at this structure. If we assume that this structure is forming or is being part of the parent chain or cut off from the parent chain, therefore there is no carbon present here. So we have a carbon, and a carbon. So for a carbon to be a primary carbon, it should be directly bonded to one carbon. So if a carbon is a primary carbon, should be directly bonded to one carbon. If a carbon is a secondary carbon, then that carbon should be bonded directly to two other carbons. So this carbon is bonded to this carbon and bonded to this carbon. So anytime we have a carbon bonded to three other carbons, then that carbon can be considered a tertiary carbon. Now that we have gotten the gist, let us try to identify the structure of this compound. Example number 1. So in identifying isostructures, we are saying that most often isostructures are seen in their Y shape. Isostructures are seen in their Y shape, whereas this part is being connected to the parent chain. Okay, so when we critically look at this structure, we could realize that this structure is in its Y shape. Another way to identify an iso compound is assuming you are on a highway driving and you get to a junction. It's either you move to your right or you move to your left. Okay, so in either direction you move, we are saying that a methyl group should be bonded directly to a central carbon. A methyl group should be bonded directly to a central carbon. So assuming we choose this direction, then we have this CH3 methyl group being bonded to the central carbon. Why are we considering this as a central carbon? Because it is bonded to this carbon and this carbon. Okay, so what if we choose the other direction? Let's consider choosing the other direction. So if we consider this direction, then we have this methyl group also bonded to the central carbon. So anytime you have a methyl group bonded to the central carbon in each direction you choose, then we can say the structure is an iso. Now that we have been able to identify this structure as an iso, what we need to do is to count entirely the number of carbons within the substituent. So we have 1, we have 2, we have 3. So in 3 count bonds we say propyl, isopropyl. Okay, let's try with this example. This part connects to the parent chain. Within this substituent, we still need to identify the parent chain, the longest continuous carbon chain. Let's assume the longest continuous carbon chain to be the horizontal part. Okay, now we have this methyl group, a substituent on a substituent. Now this methyl group is bonded to the central carbon. Why? Because this carbon is attached to two other carbons. Okay, if we cut this part, we see that this carbon is being attached to two other carbons. So this holds for iso. Now let's consider the other direction if we are going to get a methyl group bonded to the central carbon. So if another student says, why not considering this direction as our parent chain? Yes, we can. Now when we consider this part or this direction as our parent chain, this methyl group being a substituent on the substituent considered as a parent chain is bonded to the central carbon. Okay, so we say iso. We clearly say iso. Now that we have been able to identify iso, what we need to do is to count entirely the number of carbons within the substituent. So we have 1, we have 2, we have 3, and we have 4. So we say isobutyl. Okay, let's try naming sec. Assuming you are also on a highway and you get to this junction, it's either you turn to your left or you turn to your right. Okay, so now let's choose the right direction. So if we choose the right direction, we are saying that we have this as a substituent attached to this substituent considered as a parent chain, and this substituent is called ethyl. For this reason, we cannot call this structure an iso. So this structure cannot be called an iso. So we say sec. Why do we call this structure sec? We call this structure sec because the carbon which is joined to the parent chain is attached to 2 other carbons. Sec because the carbon attached to the parent chain is being connected to 2 other carbons. So we say sec. Now we need to count entirely the number of carbons within the substituent. So we have 1, we have 2, we have 3, we have 4. So we say sec-butyl. Okay, now let's try to identify Tert. So anytime we have a carbon attached to the parent chain and is being bonded by other 3 carbons or another 3 carbons, we can call it Tert. If we have a carbon which is attached to a parent chain and bonded to 3 other carbons, can be considered as Tert. Now we need to count the number of carbons present. So we have 1, 2, 3, and 4. So we say Tert-butyl. Now let's try to name neo compound. So anytime we have a carbon bonded to 4 other carbons, then that carbon can be considered as neo. Always know that in neo compound they lack hydrogen. In neo compound they lack hydrogen. So now this structure can be called neo. We need to count entirely the number of carbons present. So we have 1, 2, 3, 4, and 5. So we say neopentyl. Let's try with example number 5. Example number 5, the first attempt is we need to consider our longest carbon chain. So assuming we consider this part or this direction to be our longest continuous carbon chain, then why are we saying this part is called an isobutyl group? This part is considered an isobutyl group because we have a substituent here called methyl, and this methyl group is attached to a central carbon. This carbon is being bonded to 2 other carbons. Okay, it's attached to this carbon, so it is a central carbon. Now let's assume that another student says, why not choosing our longest continuous chain in this direction? So if we consider our longest continuous chain in this direction, then this becomes a substituent, which is also a methyl group. So anytime we have a methyl group bonded to the central carbon attached to 2 other carbons, becomes an iso, or mostly seen in their Y shape. So iso. Very good. Now let's consider this structure over here. Let's consider this structure. So anytime we have a carbon attached to the parent chain, if we have a carbon which is attached to the parent chain and it is bonded by 3 other carbons, then we can call this carbon as a Tert. So we say Tert-butyl group. Okay, now let's consider this structure. Good. Now anytime you see a structure of this form, now we are saying that on the highway, when you get to this junction, you either go this direction or you go this direction. Good. Now if we consider this direction, Okay, we have a substituent over here, which is Ca3. So in this case, it means within the substituent, we need to choose a parent chain within the substituent. So considering this direction to be a parent chain within the substituent, then this methyl group becomes a substituent on a substituent. Now, if we consider the other direction, what if we consider the other direction? If we consider this direction, now this becomes a substituent on a substituent considered as a parent chain. Okay, now this substituent is called ethyl, therefore it does not classify, or it cannot be classified as an iso. Why? Because in the directions you move, you have one methyl and one ethyl. So in this case, we say this structure is considered as a sec-butyl. Why? Because for sec-butyl, the carbon attached to the parent chain should be combined or should be joined to two other carbons. The carbon attached to the parent chain should be directly bonded to two other carbons. So this compound or this structure here can be considered a sec-butyl group. Okay, now let's consider example number 6. So in case we choose our parent chain in this direction, okay, let's number our parent chain. We have 1, 2, 3, we have 4, we have 5, we have 6, we have 7, we have 8. Great. So now this side becomes our substituent. So within the substituent, we need to identify a parent chain within the substituent. So if you are on a highway and you get to this junction, it's either you move in this direction, or you move in this direction, or you move in this direction. Now to choose a parent chain within a substituent, we still need to consider the longest continuous carbon chain. Okay, but however, in all the three ways, we will still have the same number of carbon. So let's assume this part to be our parent chain. Now that we have been able to identify our parent chain within the substituent, now we need to number our parent chain within the substituent. In numbering, remember that always you need to number in a way that the substituent receives the lowest possible count. So we start counting from 1, carbon, and 2. So we have a methyl and a methyl bonded to one carbon. So because we have the same substituent name, we bring in the prefix di. So we say 1,1-dimethyl. Now this parent chain has 2 carbon and is a substituent on a parent chain. So we say ethyl. So 1,1-dimethyl ethyl. Now the entire substituent here is being bonded to the position number 4 on the parent chain. So we say 4. So we say 4,1,1-dimethyl ethyl. Then we add the parent name octane. Great. If we don't want to name this in this way, then we can also consider this as a Tert. Why? Because the carbon here attached to the parent chain should be bonded to 3 carbons. Okay? The carbon here, which is attached to the parent chain, should be bonded to 3 other carbons. In that way, we can consider this carbon to be a Tert, a tertiary carbon. So we say 4 Tert-butyl. We have to count entirely the number of carbons present within the substituent. So we have 1, we have 2, we have 3, and we have 4. So we say butyl. Then what is the position of this substituent on the parent chain? So we say 4. So 4 Tert-butyl octane. Great. I believe that you really enjoyed this lesson. Please like and subscribe for more videos. Thank you for watching.